Okay, in this video we're supposed to identify, well, this is the skills practice that goes with our 7.2 section. Test for parallelograms. This actually came from Glencoe text. Here in number 1 we have a quadrilateral that shows that we have a pair of sides that are both parallel and congruent, a pair of opposite sides both parallel and congruent. That's one property that will guarantee that we do have a parallelogram. Here in number 2 we have two pairs of opposite angles that are congruent. That's also a property that guarantees that we have a parallelogram. Number 3, we have one pair of opposite sides marked as congruent. That doesn't guarantee that we have a parallelogram. And here we have two pairs of opposite sides marked as congruent. That is enough to force that quadrilateral in number 4 to be a parallelogram. Let's look at number 5 here. Graph each quadrilateral with the given vertices, determine whether it's a parallelogram, justify your answer for number 5 using the slope formula. So we're going to go over here to the graph paper. Here's number 5 in red, and we want to use the slope formula. So what we need to do is see if the slope of QP is equal to the slope of SY, and also whether the slope of PY is equal to the slope of QS. So we can see that PY and QS are horizontal lines. They both have a slope of 0, so those are going to match, but we need to check the QP and the SY. So the slope, change in Y over change in X, from P to Q, 1, 2, 3, 4 for the change in Y. Change in X, 1, 2, 3. So 4/3 is the slope of QP. Let's find the slope of PY. No, the slope of SY rather. SY, change in Y, 1, 2, 3, 4. Change in X, positive 1, 2, 3, 4/3. The slopes are the same. The slopes are the same. Yes, it's a parallelogram using the slopes to verify. Let's go back to the other question. For number 6, use the distance and the slope formulas. So let's look at number 6. So what we want to do is with distance and slope, let's see if this RT and SZ are the same slope. So is the slope of RT equal to the slope of SC? And then is the length of RT equal to the length of SC? These are the two things we need to check. If they are, then we have the case where we have a pair of opposite sides that are both congruent and parallel, and that's enough to guarantee that we have a parallelogram. So we need to find the slope of RT. We do this in green. So RT, change in Y is 2. Change in X, doing RT, is -1. So the slope is a -2. The slope of SC, the Y, is 1, 2, 3. Whoops, is that right? 1, 2. Oh, this was 3. So this is -3. Here the slope is 3, or the Y, change in Y is 3, and we have a -1 for the change in X. So we get a -3. So they are parallel to each other. Now, are they the same length? So to do the same length, we need to use the distance formula. So the distance is the square root of the difference of the x's squared and the difference of the y squared. So x2 minus x1 squared plus y2 minus y1 squared. That's the slope formula, and you take the square root of that, or the distance formula. So the difference of the x's between, so we're doing distance RT. The x for r, let's look at the coordinates up here. The x for r is a -2, or the x for r is a 1, so we'll do 1, we're going to t. 1 take away 2 is a -1, and difference of the y's from r to t is 3, so we have -1 squared plus 3 squared. So we have -1 squared, square root of -1 squared plus 3 squared. That's going to give us square root of 10. And the distance from SC then is going to be the difference of the x's squared plus the difference of the y's squared. So the difference of the x's squared for, we're going from S to Z. -2 take away -1 is -2 plus 1, which is a -1. And 1 take away -2 is 1 plus 2, which is 3. So we have another -1 and a 3. It's going to be the same thing. -1 squared plus 3 squared equals square root of 10. So these two distances are the same. They're a little bit more than 3. And we've shown that that one pair of sides is both one pair sides, opposite sides, both congruent and parallel. So that's enough to make it a parallelogram. Let's go back to the other page. We want to use the midpoint formula for this one. I'm not so sure about the midpoint thing going on here, but let's try this. So we'll put orange line here. So what we want to do is let's look at this diagonal and find the coordinates of the midpoint of that diagonal. So the midpoint of the diagonal is like the average of the x's and the average of the y's. So we're doing w and y, and then we're going to do n and r and see if we end up with them being bisectors of each other. That might be what they're looking for this. Let me switch over to blue here. So the midpoint formula, you average the x's and you average the y's. So w to y is a 2 plus a -2 is 0. 0 divided by 2 is 0. So the midpoint of wy in the x's is going to be 0. And do the same thing for the y's. Add the y's and take the average. W and w, the y that goes with w is a 5. The w that goes with y is a -3. 5 plus a -3 is a 2. 2 divided by 2 is 1. So over 0 and up 1 is the midpoint of wy. Let's do the same thing for nr. So we want the midpoint of nr. Now if the midpoint ends up exactly the same place, then we can say that they bisect each other because they share the same midpoint. So nr, the difference of the x's, or the average of the x's from n to r, we're doing a -3 with a 3 that gives us a 0. 0 divided by 2 is 0. And adding the y's up, we've got a 1 with a 3, that's a 4. Make sure, nr, 1 with a 3 is a 4, and 4 divided by 2 is a 2. So let me double check this first one up here. wy, looking at the y's from w and y, we got a 5 and a -3, that's a 2. 2 divided by 2 is 2. Look at the nr one, 3 and 1 is 2. Oh, we got to do it divided by 2. That gives us a 1. And over 0 and up 1 is also the midpoint of this segment through here. I forgot to do the divide by 2. So we've shown, using the midpoint, that both of these diagonals share the same midpoint. Midpoint bisects the diagonals, so we can say that these diagonals bisect each other. Since each diagonal goes through the midpoint of the other one, diagonals bisect. Which makes this a parallelogram. Okay, let's go back to the page. Looking at number 8. Find x and y so each quadrilateral is a parallelogram. Opposite sides need to be congruent. So 2x minus 8 has to equal x plus 16. Take away x and add 8 to both sides. X is going to be 24. Just make this a 40, and this is going to be a 40. And 2y's has to equal y plus 19 because those two opposite sides need to be congruent. So y is equal to 19. Take away y from both sides. That makes that a 38. And this is going to be a 38. So we have pairs of opposite sides congruent. Okay, let's look over here. Here the diagonals are bisecting each other. So we got 3x equals 4x minus 3. Take away 4x from both sides. Minus x equals minus 3. X equals 3, which makes this a 9. And 12 take away 3 is a 9. And going with the other diagonal, y plus 3 has to equal 2y minus 11. We're going to take away 3 from both sides, minus 14. Take away 2y's from both sides, minus y equals minus 14. Y equals 14. So this is going to be 17. And 28 take away 11 is also 17. So we've shown that the two diagonals bisect each other. Okay, let's look at number 10. Opposite angles need to be congruent if you have a parallelogram. So we can set 4x minus 35 equal to 3x plus 10 and find the x that makes them equal. So take away 3 x's, we get x. Add 35, we get 45. X is 45. 180 take away 35 is 145. 135 plus 135 plus 10 is 145. So those two are going to be congruent. Now these others also need to be congruent. We're going to set them equal to each other. 2y minus 5 equals y plus 15. Add 5 to both sides and take y away from both sides. Y is equal to 20. So this is going to make this a 35. And that makes this one 40 take away 5, which is 35. So opposite angles are congruent. It's a parallelogram. The last one. Let's look at this. Opposite sides need to be congruent. So 3, let me change colors up. So 3y plus 2 equals y plus 20. Take away y from both sides. Take away 2 from both sides. We get 2y's is equal to 18. Y equals 9. Now if y is equal to 9, we have 27, 28, 29. And we have 29. So those are congruent. Opposite sides are congruent also for the x's. So we have x plus 20 equals 3x minus 14. We're going to take 20 away from both sides and take 3x away from both sides. So take 20 away from 14, we get negative 6. And take 3x away from both sides, we get negative 2x equals negative 6. X equals 3. Now if x is equal to 3, this top side is 23. And 3 times 3 is 9. Whoops, what's going on here? Get 23, we get 9, take away 14. That's something's wrong with this one. Let me go back and redo this last one over again. Something's not right. Might be where I ran out of room and shifted downwards. Let's look. I'll do this in purple. Okay, so let's see. X plus 20 has to equal 3x minus 14. So take away 20 from both sides. I get, here I get negative 2x's. When I take 3x's away, equals negative 34. Divide by negative 2x equals 17. Now if x is 17, we got 37. And we have 51 take away 14 gives us 37. So that does make those sides congruent.